Hello, hello, hello. Good morning, evening, or afternoon. If people don't know, I'm Jay, your favorite oddity, and today I am working on my Hexapod version of Digit. I have the Fusion 360 up now because currently I'm working on the shell. So a quick little quo pro quo. I'm working on this for like I want to say 3 weeks now, and we have a lot of it pretty much done. Let's switch it here, friend. We got the legs working. It can crawl pretty well. If you've been following my social media, you've been able to see some of my work, especially of this guy working. But yesterday I ran into a problem with the shell. I found out that the shell actually is messing up the movement because of this system is designed to flex a lot and also flex while walking. And the shell was actually stopping that from happening. It was just too locked in. So I'm working on a new shell to fix that problem. If you have any ideas on how to help with that or any ideas that may work, please let me know. I'll listen to them and work it out. But right now, it's probably just going to be just me CADing on Fusion 360. As you can see, I have the project already up. And also, don't be afraid to ask any other questions you guys may have as I continue to work. I want to do these office hours, get to talk to you guys a little bit more, get to know you, get to know me a little bit more. That's how we're going to try to do this. Right now, I got the red shell up, this is the one I'm currently working with. I think I can put like a hinge here and then have it slide from this main area here. And I think that could work. I'm hoping that it works. It's still a big 50-50 thing, but that's what I'm going to be currently working on, get on the right file. But yeah. Hello from the UK. Good evening. But yeah, for people who don't know, I based Digit to be off of a roly-poly or a pill bug, they call, which aren't really bugs, they're crustaceans, which, horrible naming for branding. But yeah, I'm hoping to get this done by this weekend because there's some outdoor stuff I want to do and take this robot with me, my little guy with me. But I have to first, get stuff done. Dun, 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 dun. Click that. Should probably move that down now that I look at it. And it's also, what is this? I don't know what that is. Oh, turn it off. That way I can just see this. So in theory, this looks like it could work. I'm using Fusion 360. If you're wondering what CADing software I'm using, that's my go-to. I know there's probably other design ones you can use. SolidWorks is a good one. My friend Sean did a whole series on using FreeCAD, which I think is amazing, but I am very lazy, and I really don't want to have to learn a whole another CADing program if I don't have to. Oops, I messed up that design. Let me go back. Let me edit this. Let's see. Now take some of this, move this over here. That way we can close that, and hopefully that's fixed. Also, I know I'm not the best Fusion 360er. The one thing about being self-taught is I had to figure stuff out on my own, and I don't take it as seriously as most people do. One of my friends, Travis, introduced me into CAD competitions where people use Fusion 360 to design stuff as fast as they can, and it made me realize I am really bad at CADing in comparison. Okay, just turn that down. So I'm hoping I can slide one onto this little platform here and then have them all just link up all the way through the back and they'll all just be attached to each other. What do you mean efficiency? Like, what does it do? Or give me a little bit more. Because efficiency is just a cool robot that I like to wear and go out in places because I just am socially awkward, and bringing a robot with me makes me feel better. I don't have anything more to add to that other than that. I could make it a pass butter for anyone who doesn't know that's a Rick and Morty joke. But I think having a butter passing robot when I really don't eat out that often seems to be a bad idea. Ooh, does that mean to do that? 2 sides. That way I can kind of do this. So what I'm doing now is I'm just trying to get like an idea of how this may work. So I'm like adding little parts here and there that way I can kind of envision it better. I usually do this in my sketchbook. Like I usually do this part sketching it out, but literally last night is when I found out the shell wasn't going to work. So I was like, I'll just take a few Z's and then work on it in the morning. But I kind of, once you kind of have a vision for it, you can kind of figure it out. Originally, I was going to go with more of a spinal design, like give it like a spinal cord and make it go from like here all the way down and then have it be on top of the spinal cord. But then the spinal cord would have to be super flexible. And actually, now that I think about it, I could do that. Nope, we're going to do this first. We're going to do this first. We're going to do this first. And if this doesn't work, we'll go with the spinal connection because I have until Saturday before I have to go out and give a talk about robotics. And I'm hoping to have this done by then. I'm also going to bring Orbit with me too. If you haven't seen my other big robot, Orbit, it's huge. I love him. But we're going out this weekend to give talks and hopefully inspire some people and show off the robot in the real world. Real world. If you have any ideas or questions, please let me know. I have people in the chats that will hopefully get back to me with all of that information. That is. I also gotta figure out how I'm gonna make it go from the back too, because I have no idea how it's going to attach to the back. Like I could just make it hang over, because in theory it'll just go back and fall around and fall off. But that's just me theorizing at this point. So yeah, I'm thinking of a shell system kind of like this, which may work in theory, because then looking at the full body system, it'll be kind of like this, where all of that will hide all of the extra wires and stuff. Because I'm not sure if you guys noticed, this thing has a lot of wires because it's using what 16 servos, plus 2 power packs, plus connection wires, plus some other stuff. I'm hoping to make a smaller version in the future. I was actually talking to a few of my coworkers earlier today about a little syringe bot, but they don't approve of my idea, so I may have to redesign it, maybe make it more of a bubble blowing robot or something. But yeah, which I know this won't work like this because it won't be fully off. Gravity is going to affect it if it's going to fall. So it'll be much more like, no, I think you can still work that way. I just have to add a few more details. Hold it again, because we still need one. Yeah. Okay, it worked. This is it. Oh. Anybody else working on a robot project or anything? Okay, just walking and talking to myself. Nice. Add that there. Okay, so I kind of have an idea. I'm using 3mm holes, which I probably need to make them a bit bigger because if you use heated inserts, and you're using like a 3mm heated insert, you have to make the hole about 4mm. That way the heated insert can like be pushed in better. And I am a big fan of using heated inserts because they make my life a lot easier. Okay, these two don't look right. Go back to the shell layer. This looks off. Which body is that? Okay. Are you too close? Oh, okay, I see. Let's see if I can use my imagination and create some gravity. You know, just for people to know the gravity of the situation. Yeah, I know. That was bad, but I think it was great still. Because sadly, thanks to the concept of weight and gravity, this is still going to be kind of bendy looking for, I think. We're going to still keep it kind of fixed in place, but it won't be like a perfect and fixed place. So thanks to that, all the rest of the parts will most likely fold to that angle as well. As you study engineering, you have to always think about physics. Physics is always going to be part of engineering, and you always have to think whatever you add gravity. So I kind of start imagining things having weight to them. So like if you see something that looks like this, where it's all just stuck in the air, you got to think that it's going to have to be attacked by gravity eventually. Which sometimes works, sometimes it doesn't work, sometimes it's cool, but it also gives like a way more real look feeling to it, and I get to see how in theory this may work out when everything gets printed. And the thing about that too is I don't have that much TPU left because I've been busy printing out so many different things with TPU recently on testing stuff that may not have the best TPU designs. So like this would be more or less how it should look in theory as it goes down and weight is applied. And hopefully that's good enough to cover this guy. Actually, I'm gonna measure him really quickly. That way I can kind of figure stuff out. I'm not sure if many people do this, but I do this. I have a little pad that I can write down like measurements and stuff that I don't really think about until later. Let me see the full concept of it really quickly. Currently building a robot that looks like a nerd from Nerd Candles and pulsates and wobble really looks like Hexapod. Bigger. Nice. I don't think I know nerd candies. Do I know about the nerd candies? Like the old nerd candies, like the ones you would get in the little things. Like that's the only nerd candy I know. But that is awesome. I do want to try making a giant hexapod robot, but here's the thing. One thing I've learned about doing hexapod is one, thanks to more technology happening and more easier way to get coding and figure out algorithms with helps of ChatGPT, you can make a hexapod pretty easily, but there's still issues with figuring out the walk system. And then one of the hard problems that I found out, which I learned yesterday, if any of these servos burn out, the entire system stops working. So like the problem that I had yesterday was this head servo, the one that does his head, because if I tilt Stitch's head anyway, his head starts going in the opposite direction to balance itself out. This servo burnt out on me yesterday, and the entire system stopped working. Like the power wouldn't go. I kept having brownouts, and me and a coworker were trying to like figure it out. We were just testing stuff, and I found out once it was the servo that any of these servos ever brown out for whatever reason, the system will stop. So if I make a bigger version of this, like a really big version, like big as this table, giant creepy hexapod spider thing, the servos will have to be really good and I have to have replacements, because if any one of those servos, which let's be real, you'd be using about 16 servos to make a decent hexapod. If one burns out, the entire system will stop working, which is a problem, of course. Oh, so there are little nerd candies. Okay. That's pretty awesome. I enjoy that. Nerd candies are awesome. This one's just really awesome for me because, like, I'm gonna make a video post about this, hopefully once this is done. But my main goal for making the walking robot, and also why I haven't started my drone yet, Digit's birthday was February 25th, which it's weird to have a robot have a birthday, but mine does. Moving on. And something that occurred to me is that most human children at the ages of 1 can usually crawl and walk and do other stuff. And Digit didn't have any legs to do that, so I wanted to like fix that problem. Because why wouldn't you want your robot to be able to walk? So that's how that started. The cool thing about this being on a TPU is I can definitely flex that out more. But this is kind of like a late birthday gift for my own robot, for it can be able to walk. I haven't figured out the sensors yet for it, because right now it just walks forward. I haven't figured out what type of sensors I want to add to it for it to actually like move around the world better. Because I was thinking ultrasonic sensor, but like first I have to find out where to place that, and then 2, I'm not a big fan of the ultrasonic sensors design, because like the 2 holes, like you have to find out where that would fit on the body, which sounds ridiculous, but to me it's important. And that's like one of the hardest things to like figure out when it comes to this. Okay, let's see. I think one of my printers is free, which means I get to test printing out one of these extra shells. Give me 1 second. I'm going to save this one. And then I'm going to see if I can get it set up on my bamboo. I think there's something on the pill plate really quickly. Yeah, you can give me a quick pause. I'm going to go set up my printer really quickly. I have returned. Waha! This is something I was trying earlier, which didn't work. So we're going to try this one. I'm printing this out in TPU from the AMS on my bamboo. The TPS or TPU on the AMS bamboo is just like normal TPU, but it's a bit stronger. I've noticed that it's like a lot tougher, which is good, because you don't want it to like easily break, but at the same time it's still pretty flexible. But I also have another one being printed on my Cruiser as well. But the faster I get this done, the more we can test, the more we can actually see if it actually works or not. All right, go back to the Fusion file. So yeah, that's what's currently happening. Hopefully it won't take me too long. And I need to also get that other part that I just created. What part is that? That's the one I did right here. That's part 29. Control V really quickly. Make another one. I always make extras of like every body part I always do, because I'm always afraid that I'm going to mess up somewhere in between and like mess up the design somehow. So I do my best to like cat around. But this should be the main holding point in theory for our shell design. It should hold it from the top here and go all the way back. I am a bit worried because I'm going to have this open space right here, which is just going to be like a problem. Oh yeah, the bamboo TPU is really good. Like, if you haven't tried it yet, I recommend it, because it's just like normal TPU, but just a bit tougher, which is good. But you do like a little bit more flexibility. So like, it'll still flex, just not as like overly flexing like these. Which you got to make sacrifices when you're doing science. Let's see. I think that's all I can do for right now with this, as I wait for prints to finish. I have one that's on my Cruiser, like I said, is about to be finished soon. If anyone has any questions, comments, concerns, pains, traumas? But yeah, hoping that'll work. I'm still gonna stick to my white, orange, black color scheme because like I just like that color scheme. It just looks red here because I just needed to be able to see it. But I do have, I can show you guys, I do have another one that I'm working on for the future, which will be for you guys. It'll be fully open source. And this is my crawler project. This one will be totally open source. We're trying to get to work on the Adafruit Feather, but it'll have servo control walking system and then a little servo controlled eye system. I printed out these parts, like I have these parts on my desk right now. I just haven't assembled anything, but I'm trying to get this to work with the controller system. That way I can easily give people like a quadrupod they can control with a little controller. Looks like you need to add some dragon wings. I've thought about that. It's the problem with that is like this thing, when it's being worn, it's just a lot. So like, here, let me grab him as an example. When I wear Digit flexes a lot. So like if I add wings back here, the wings will have to be like this kind of in a weird way. And I'm not sure. Oh, hold on. A magnet got stuck to my thing. Give me that. I'm not sure how well that will work. Because like right now I can just take them, strap them on my shoulder, and then move the feet a bit. And he does a pretty good job even without the stuff he's supposed to have on. So like, see, he holds on pretty well. It's comfortable. But with the wings, it'll shoot out more backwards, and I'm really worried that that's going to get in the way or hit somebody by accident. But I have thought about designing some like solar panel looking wings, you know? That way I can like charge one of the batteries as it does stuff. But yeah, let me get the main screen. Yeah, so like, this is the problem that we're having. We have to cover all of this, because I can't let all of this just be out, because then it would just mess up a whole bunch of stuff. Hey, Becky! I'm working on the Digit Hexapod. So yeah, I have to design the shell to cover all of this because I can't let all this out. But on the bright side too, hold on, let me move some stuff around. The crawling for this little guy is pretty good. Like, I'm still pretty proud of that because I've never been able to make a robot crawl before. So if I press this button and then this button, it'll start crawling towards you, which is super cute. The body flexes a bit as it walks, and you can kind of see it. And it just drags itself forward. Oh, I gotcha. It's like a very, very funny puppy. So yeah, and I also designed it for I could turn off the walking system because I don't want these legs moving on my back, because if you haven't noticed, I have very long hair, and I've had situations before where a robot has gotten stuck in my hair, and I have never wanted to football throw a robot before, but there's something particularly disrespectful when a robot starts pulling on your hair. It hurts, and also it gets kind of annoying. Going back to the Fusion file. So yeah, right now my printer should be going, which it looks like it is. Let me just take a quick little view here and make sure it's going. Yeah, we're doing good. So hopefully that will be done pretty soon, soonish. And I can have more for this. Back to the Fusion file. Oh yeah, no. One thing about making wearables, like I know eventually in the future I may have to start writing and like actually doing like books and stuff like that. And I do want more people to make wearable robots, but I want them to be made with your own personal design. Like I don't want you to make a Digit. I want you to make whatever design that you want to make. Like if it's a crab, a butterfly, ladybug, doesn't matter, a dragon. Because I know people are really into fantasy, can build a robot dragon. I want it to be more you. So eventually in the future, I'm going to have to sit down and like write down all the different ways to make a wearable robot and the pros and cons for each way. Because this one is just brand new and it works for me, but I had to go out of my way to like design custom clothing to make it work. Compared to like using the GoPro technique, which the GoPro technique works, but you have to worry about it tilting to the side in a weird way. And then also it's not a lot of outfits can pull off the GoPro look, you know, because let's be real, we gotta be fashionable. We gotta be fashionable. It's very important. And then there's other ways and stuff like you can do it too, because the GoPro approach, just the backpack approach, which I did that a lot. But the backpack approach, of course, only really works when you're going outside and doing a whole bunch of stuff, because wearing a backpack like right now when I'm doing this would just look embarrassing for everyone involved, including me. But there's always other approaches you can always just like try to sit down and figure out and like do, and that's always a good thing. But yeah, definitely be careful of having moving parts near your hair. And there's a video out there that DigiKey does have with Digit, was that one 03? Yeah, Digit 03 smacking me in the face while we were trying to record because his head retilted and then just slapped me straight in the face, and it was a whole problem. They laughed, I groaned. It's out there on the internet somewhere. Eventually they'll post it, I'm sure, but it's not one of my prouder moments of being a robot parent. But yeah, next one's going to be definitely this guy. This one's going to be small and it'll be radio controlled. And this one I will make open source for people to make their own quadrupod that can easily be controlled with a controller. Because there's a whole bunch of tutorials for quadrupods and hexapods out there, but from what I was learning while I was building this guy, they're not really all easily understandable, and I kind of want to like fix that problem. I want something that can be like easily like, oh, take my code and upload it and just follow my instructions, and then that's it. You don't have to sit around and like figure out the algorithm and stuff, because this took forever to figure out the walking. Like, I don't want to have to program like that again, because that was like 4 days of programming and trial and error. And as people know me personally, I do not like programming. Programming is the worst. I stand by it. It's the hardest. If I don't have to program, I wouldn't. But here we are. All right, waiting for more parts to be finished pretty soon. I will be at Open Source this summer. I'm not sure of DigiKey sponsoring. That's a bit above my that's a bit past my pay grade. Oh no, they don't tell me much. I hope they will. But yeah, definitely open source. I'm really hoping to open source. I got like specially designed digit stickers, and I'm also gonna have other stuff that if you have a wearable robot and we run into each other at open source, I want to be able to give you a little like special little something, you know, like here's a special like sticker or whatever. And then we can just talk shop, because I love talking shop about people's projects. And last year there were 2 individuals that I ran to who had their own wearable robots on their shoulders, and I was so happy. But sadly, I lost some of those pictures. If you are that person or one of those people who are like watching me right now, please tag me in the thing, because I love seeing it, and I am so upset that I had the picture in my phone, but then I switched phones and a lot of my old photos got deleted, and I had to just accept that. But yeah, where can I learn to make these kind of products? I mean, from foundation, digital design, so no foundation on this subject. Honestly, that's a hard question. Since I'm like self-taught, a lot of my work is literally just me playing around. But if I had to say what are the best things to like learn, of course, is the basics. I would say first focus on, I think cosplay is a good way of getting into this type of situation, because a lot of cosplayers unknowingly have the design skills, but they usually focus on just, you know, making the design from their favorite show or whatever. But if you take the same concept as cosplayers, make your own design and give it its own function, it's pretty much the same thing, except I guess I'm cosplaying as myself, which, let's be real, I am flattered to cosplay myself. I enjoy myself. But point is, that's usually a pretty good foundation, and it always depends too if you're trying to, what you're trying to do with it, because like Digit's cool and all, but like this wouldn't make it as a product. Like, I'm not sure if you guys heard about the robots that recently shut down and had to tell all their users goodbye. It's really hard to have a robotic anything right now be a fully functioning system that actually gives profits. And as we are in a very profit-based society, unless there's like something Digit can do where it like walks around and like, I don't know, shoots out bug spray to keep bugs out of your house, which you can probably add that to like a Roomba. I don't really see it being used as like a normal thing. Plus, there's still a lot more upgrades I want to do because this one looks good. Like it looks like a suitable. Ooh, this rhymes. I gotta fix that part of the show. Um, it looks like a suitable product and a suitable thing, but at the same time, like if you don't really have a future plan for it or anything like that, then it's just going to end up being somewhere like in a dump or in some kid's toy chest. Give me a second. I think I'm gonna use a 3-slot arc. I'm still getting used to using some of these tools because, like, you would think I'll use a lot of these tools more often, but I don't. I probably should, but I don't. But if I add a 3-slot here, right there on the bottom, oops, let me extrude 3. I know it's weird to have like a favorite number, but 3 is definitely becoming one of my favorite numbers. And not pi, the 3 1.4, but just like 3 as by itself. It's just a good number. But anyway, I was thinking I could have this type of hinge design in the back, which in theory could hold the last part of this. That'd make it a bit longer too, though. But like, if I can have that in the back to keep it off from falling off, I think that could work, right? In theory. How did I learn Fusion? That's a very good question. I learned Fusion by trial and error. I got really lucky in college because during my college time in art school, they had Fusion had a free service that if you were a college student and you had a college email, you can get Fusion for free. So that's why I did. I got Fusion for free when I was in school, and I just played with it like all the time. Like I would just CAD circles, squares, and just try to design stuff and make stuff as I went along. And of course, I'm not a student anymore, so I have to pay for it. But that's kind of how I just learned it. I just kept playing with it until I got decently good at it. I thought about getting into Blender, but Blender scares me. Blender seems to be a lot harder than I would enjoy. Blender is very much a lot more difficult in my opinion. Plus, like I have friends in animation, and I remember in school that one of the biggest fears for them, they used to always be saving constantly because they're always afraid that while they're working, suddenly Blender would just stop on them. And that's like always been like a horror story for like all animation majors, is that while you're working on something and something just happens and it just freezes on you. And I'm not sure how true that is, but yeah. Oh yeah, it's the perfect way of doing stuff. Is using it as a teacher, as a student, just playing around with it. But also, you gotta think about it. It's like it's something that I've noticed from everything going on. The hardest thing for a lot of tinkers and like makers is always like motivation. So you have to like kind of, let's say cosplay is a good way or good entry point of it. Like I love the art of cosplay, not part of the cosplay community myself. But having that motivation to learn, to build your favorite thing from whatever movie and stuff like that, that could be what you need to just learn the concepts. Because once you understand the basics of like design and stuff like that, the rest gets super easy really fast. Into mirror parts, click, and then to mirror plane, which I will go for over here. And then make it into a new body, perfect. So in theory, these 2 points will hold on to here, and then they'll slide down. I still need to make something to cover this part though. I don't want people looking at my robot's backside while I'm wearing them. The thing about this too is when you really go out and like test this. Oh yeah, definitely. See, my self-motivation was pretty much I wanted a robot best friend, so I just built the thing I wanted. And it's been years of like trial and error. I think last year when I first designed Digit was when I finally sat down and said I need to have one singular idea and work on it. Because I keep juggling multiple robot ideas. Like I'm always like, I want to build this, I want to build that, I want to build this, I want to build that. but I didn't have like a main robot. I had my main robot Aussie for a while, but Aussie wasn't as cool as I wanted them to be because it was a spider design that wasn't a hexapod. So I got a lot of like comments of being like, why does it look like a spider that doesn't crawl? Like you get a lot of people who are always going to be on you on things like that. And I'm not gonna lie, I was a little insecure. I felt that, so I didn't want to really work on Aussie anymore. So I went on other stuff to make bigger robots. And then when I finally came back, I was like, I want to have my own thing. So I went for a bug design. University email. Can I get a renewed future student license? I think so, yeah. Also, hi, Cat. I don't know, it says a cat, but hello, Cat. Definitely, I believe you definitely can get a health infusion while you're a student. Honestly, it's like the perfect time to learn when you're a student too, because you just have a lot more free time to play around with stuff. Don't get me wrong, I love what I do, but I also don't have an outside life. This is pretty much all I do all day, except for going to like the gym and then sometime touching grass. But throughout my day, I'm just doing this. There's still so much to like worry about and think when you're like designing. And like, kind of show you guys this because we're talking about it. My sketchbook is completely full of like different designs. So let me. Where's my top-down camera? Okay, I'm not sure if you guys can. Oh, you kind of see it. Yeah, so like my sketchbook is full of like all my original designs. Like I'll work on these and just sketch stuff out. I'm not sure if that's upside down or not. It's upside down. Oh, okay, yeah, it's upside down. So yeah, I'll just sketch up ideas and like try out different designs and stuff. Like these are really original designs just for the hinges because I wanted them to move a little bit better than they do now. It kind of works, but it was a little bit too much. And then like this was a controller glove I was working on, which I'm still working on, for I can control the robots better in a more fun way. This is my digit page when I was like trying to figure out the hexapod movements. I printed this out once I had the design pretty much figured out, but like I sketched out the foot originally first, then I had to do the math of like which one was where, for I wouldn't forget which foot. My sketchbook looks pretty cool because of this, because it's just a whole bunch of notes on my robot projects. But like having a little notebook for this while you take notes is kind of like a good way of learning and just a good way of like having fun with it. Because there are things you're going to forget, and like a good example, like from way back here, I have a page. Give me a second. I keep forgetting what pins do what in digits sometimes, so I had to like save a page in here just for that. Or also too with Orbit, like I had a whole thing with Orbit in here. I have like my Orbit page, and I was trying to figure out which pins did what, so I had to like write them down and like take notes on like how heavy he is. Try to tank treads, how many treads it actually took me. Took 38 of those little white parts to get the treads working correctly. But taking notes like this is just super helpful. It'll come up with more cool ideas as you're like going about and you're trying different mechanisms too, because like other ideas. But I recommend just having fun with it. Like don't make it have any real purpose. Just note taking being very important. Just little teacher moment of documentation. All right, we'll put that back to future. But yeah, just don't forget to document your work. It's very important. The difference between science and having fun, documentation. I'm pretty sure Adam Savage said that. I'm pretty sure. 50-50. Yeah. So hopefully in the end, I'll have this done this weekend, and then I can do more stuff. Also, since some of you guys are here right now, what type of more content do you guys actually want to see from my page? Like, I know I'm doing my robot series where I'm like, can we make it real? I have 3 videos in the queue for that. I'm doing Bender from Futurama, 1-1 from Infinity Train, and then the Terminator robot. Those will be my next 3. But I also kind of want to work on some like fun cinematic stuff, but I'm not really sure. Educational videos, I'm not really that great at. Like I can somewhat explain what I'm doing, but as you can see, I'm very scattered brain. I blame ADHD. So like it can go left or right most of the time, depending on what's happening. But if you have any, ideas or questions, please let me know. Also, just pointing out, I can pretty much only see the YouTube stream right now, so I do apologize if you're posting or asking questions anywhere else. I can't see them. I think this one is pretty much ready. Oh, my part's finished. Give me 1 second. Hey, Yeti, can we go pause really quickly? So I got this one off of the my Prusa. It's a quick print. I didn't follow the instructions, so it doesn't look that great. But this is a perfect like test example to see if this can kind of somewhat work, depending on how we do this. Let me turn it sideways a bit. Try and get like a good angle for the camera for you guys. I'm a freshman student. Where can I learn ROS, PID, and robotics? I'm not a university student. I went to art school. I learned all that from books and YouTube. Like I actually have an ROS book on my shelf over there that I read recently because I had to install a virtual environment to work with it because you have to like use Linux for it. But a lot of the information you really want to know is already out there. But yeah, see, like this is the piece that's right here, so the first shell piece. Yeah, it looks like it could work. Yeah. We have to get that middle piece in there and then go from there. But yeah, this could in fact work for us, which is the goal. Personally, I say if you really want to start off with robotics and stuff, start small. Everyone wants to just go big and start with like a whole AI system. Like I keep telling people, start small, move a single servo, turn on an LED, something small as that, and then you can keep growing as you go. Because like even my first project, which I still have on my shelf, it's really small and really bad, but all it does is lights up and spins around. That's it. That's all it does. And that was back in 20, I want to say 15, 16. That's when I first finished that project, and I loved it too. But like you can't just skip the hard work and experience. It would be nice if you could, but sadly that magic doesn't work yet. Or like the Matrix, we can like plug our brains into the system and then find out. Give me one moment. I am trying to find a file which will show more. But yeah, make sure I save too. Make sure you save your files. Fusion does save everything by itself. So like even if something were to happen and you like click out of it, it usually saves itself, which is nice. Very big deal. Kind of a big deal. I did notice in this one too, the endpoints, maybe because I like printed this out super fast, don't really look too good. It's like a lot of frailing. Hold on, let me switch the camera. There's like a lot of frailing there. That's on me because like I hit fastest, so like it doesn't look good. So I'm gonna have to reprint it. But at least now I know like the structure of it and then like how it can actually fit on the robot, because like it does look pretty good as a shell, like that. I'm also gonna have to make some with holes in them because I have button switches I have to hit. But don't be afraid to make mistakes. Don't be afraid to mess up. As long as you learn from your mistakes, you're not failing. You're just improvising. I like that. You're not failing. What I am going to do is make that a little bit bigger. So I'm going to go back to the shell here. Close this. Take this. Another copy of it just in case. Move it to the side. I have to move it to the side because like I said, I'm always scared to mess something up with the design, so I always make copies. I've had so many situations because like down here on Fusion, this is like your history, so you can go back really far. but I've messed up sometimes and messed up my history, and it's a whole thing. But I'm going to make this about 3 millimeters longer. Also, I measure in millimeters, so please don't tell me inches or whatever, because I don't know. In my defense, I blame the school system. May I know where are you doing, Mr. Jackpot? Mr. J. Oh, I'm making Digit Show. If you're just coming in, sorry, I should have said this. If you're just coming in, I'm working on Digit Shell right now. Digit's been super great. We got the crawling system working and stuff. It's super cute, but like all this stuff needs to be hidden now. My last shell design that I tried working on last night failed. I did a video. If you're on my Twitter, you saw it. It didn't work out. The main problem was that it didn't flex, and the main goal of Digit and the thing Digit really needs to do outside of all of this is be flexible. And since the shell didn't flex, the body couldn't be worn on me correctly. Like it kept trying to like hold itself up like a really weird muscle. And it also couldn't walk correctly because when this thing walks, it actually bends a bit that helps it get friction. It's one of those little nicks I found out when I was working on it. I'll show that in a second if you guys want to see it. So now I'm working on a new shell that's a lot more flexible that in hopes I can get this working. Hold on, get this together now. But that's the goal, at least. I want this to be like, you know, fully functioning, cool robot thingy. I'm hoping to get it done this before this Saturday because I have to go out and talk to some people and I want to have my robot with me. Plus, it always looks cool when you get to like take your robot with you and like show off to people. Like, look, this cool robot I made. So that's what I'm aiming for currently. Plus, we have to like figure out this part too. If you guys have any other ideas and stuff, I'm like I said, open to ideas. Because I still have to find something to cover his tush. Will be nice to say tush. Pectoral? No, that's gross. Pectoral is a different part of the body. But yeah, buttocks. I need to cover his buttocks, and I don't want any of his wires coming out or stuff like that. But it won't be a perfect design, but it will be definitely functional. Plus, there's some more artistic value I want to add to it as well, which I haven't figured out yet. I've been using the colors orange and white for a lot of the designs, which I still want to do, but I wanted to have a little bit more NASA punk-inspired design to it. If people are just new here, you don't know, but aesthetic is very important in your designs. So like if you want something to look a certain way, you look up the aesthetic. A good example, ooh, that's horrible, I'm over too much. A good example is like when you see steampunk, steampunk is usually like a whole bunch of coppers, gears, golds, like that's how you know it's steampunk. And then you have to make sure the gears are shown so you can show the gears being like worked on and moving and stuff. Give it a lobster tail. I could give it a lobster tail, but like it can't drag. Okay, that was a problem I had. Fun story for people who are entering, which I hope I'll get in trouble for. When it had this other design, it kind of worked, but the problem was I had all this battery stuff and a other tail in the back. And I thought it was fine. Like the video I showed me wearing it did pretty good. But then one of my coworkers was like, "Its butt's big," and I was like, "Oh my god!" I feel like my robot feels embarrassed, and so does I. So like we had to redesign it because we got critiqued on how big its butt was. So like, you know, it was a learning moment for everyone involved. But yeah. Yes. For making printable CAD models of Project how do you perfect it and design will work. It's a bit 50-50 because I'm not sure if the design will work. A lot of this design did not work. Like a lot has changed from the first version of Digit. What I end up doing is I focus on one task at a time. So like it could be like, all right, first get the head working. Once you get the head working, it's totally fine, and then you can get that part, you know, together. The next is like, all right, let's get the walking motion. If you were following along when I was working on this project before, originally it had 4 legs. and I have video of it like learning how to crawl because originally I couldn't figure out how to do the algorithm correctly for it to like move its feet back and forth for a crawling motion. So instead, I had both of the feet move in more of a like swim motion, so they would go up and back and pull and up, back and pull. Um, and that did well. And then after I learned that, I kept going forward, and I was like, all right, cool. We have that motion. Let's add two more legs and see if we can like get it moving and walking. And then I learned about oscillation, which you have to use to make sure the robot move correctly. Because of the speed thing, you can't just tell it to go through that whole thing. You have to add an oscillation for the movement of the feet, and then so on and so forth. But when it comes to like designing this and stuff like that, once you start designing for a while, you kind of get the idea of how things are going to fit. So like this right here, I can see is off for the fact that it's fusing in with this, but also I know that gravity is a thing. So like if I add this to this, even with all the parts in there, it's going to slouch down, and I have to like mentally prepare for that. So like since I know how things react in the real world, I'm just the digital world, I can usually see designs and mechanisms in my head at this point and figure out if that's going to work or if not. And sometimes I've been wrong. Sometimes I have to like try it to see if I'm wrong. Also, don't be afraid to ask for friends' help because I'm not the brightest bulb in the system, and I do go and ask for help when I need it. So one of my favorite makers is a woman named Deborah, but also known as Geek Mom. She does amazing LED work. Like my clock arm jacket, that's like my favorite jacket. That's all her. Literally, every time I have an LED problem where I'm like, hey, I don't know how to design this, I will go to her and get her feedback. Like, oh, if you want LEDs to work like this, do this instead, or try adding this to this. Or if it's more of a situation where it's coding, my friend Sean, who I love to bother Sean. Like I find it a great pleasure to just mess with him. I'll like ask him like, hey, does this coding thing sound plausible? Does it sound plausible to like code? Like when we first worked together on our last AI thing, it was like, hey, can we make a local large language model talk using Piper TTS? And he was like, sure. And then we ended up collabing on it because he's smarter than I am, and there's no way I was gonna figure that out by myself. But yeah, so like 110% making people out there, make friends, make people. Don't be afraid to get critiqued as long as they're coming with helpful for critique. Because like, don't get me wrong, I'm still human, so like I feel bad if people call my stuff bad, but like if they're coming with helpful critiques, make sure you keep that, like, okay, if he's helping, like, hey, don't try this, compared to someone who's just jealous of your work and is just gonna hate because they're a hater. There's gonna be those people regardless. Is this any electric components because DigiKey is electrical component distributor are there? Yes, all the electrical parts for this project is all distributed at DigiKey. Part of my job at marketing is when I do work on projects, I have to make sure that a lot of them we have in DigiKey. So when I do a write-up and stuff, I can be like, oh, it's a full DigiKey product. And then that way I don't use parts that they don't have sometimes, and or it gives me a good chance to like test stuff. So like a good example for this one, let me turn on the other camera. A good example for this, because I didn't use these before. These are, the battery packs are Seed power boosters 1000. It's giving me the power that I need for Digit's crawling system. I've never used these before, but they're recommended to me, and I was able to wire them up really well. They're controlled by this button here. And now when people ask me like, hey, if I need a power booster, what power booster should I use? And I can recommend this now because I know what I'm doing with it. I do not like recommending parts that I don't know how to use because I feel like that's just bad practice. Plus, it's just fun to like be able to have new parts. I'm a part goblin. Like if something were ever to, if I were ever turned into a dragon to collect things, I would be like collecting circuit boards, servos, copper wire. I would just be collecting electrical components and then hoarding them. But luckily, I'm not a dragon yet, so. Don't accept criticism from anyone you wouldn't take advice from. Oh, that's a good mantra. Becky, I'm gonna take that one from you. Becky posted one of her favorite mantras is don't accept criticism from anyone you wouldn't take advice from. That's a good one. That's a good one. But yeah, definitely work on these type of things. You definitely, I believe, anyone can do it too, and that's like the thing, and that's why I like to show about my work is I've been doing this for a while, so I seem like a pro, but because I'm self-taught, I'm a walking definition of anyone can do it. It may seem hard now. It'll always seem hard when you first have to like jump in, but it gets easier. And like I said, motivation, have fun with it. Don't I think one thing about school which makes school very hard is that you're doing it for a grade. So it's so much pressure on finishing the project instead of just learning the concept and having fun. Because I'm all about the funs, the kicks and giggles. I'm the type of person that'd be like, oh, science, let's try this. And then I'll like call one of my coworkers on a call and be like, I'm not sure if this is going to work, and it could explode in my face. And if it does, call an ambulance for me because I live alone. But I'm always excited to just try it. Like worst case scenario, you get like a capacitor popping and a loud noise. It's scary, but you can get back to it. Or you can fry a board. I've fried about 7 boards this year, if I'm counting correctly. No, 5 because of the servo controllers. I fried a servo controller when I was working on this the first few times because of wiring issues. Also, I didn't know that I needed to put a capacitor on it. Luckily, I was told to put a capacitor on it. And so far, it's been really good. But yeah, so like this should work in theory. So like this one will hold up to the top, and then the gravity will make this fall a little bit. Some of it may not work this way because the parts in here are pretty high up. But in theory, this should work on covering parts. The only bad thing about this design is that since it's just like this, you'll still be able to see through it under here. So I'm not sure if I'm comfortable with leaving this area kind of like open for things. We'll have to see. Because on one hand, if I keep the wires kind of somewhat showing, it gives it kind of a more like realistic sci-fi vibe to it, which I'm always down for. Because the thing about NASA Punk and a lot of like designs like that is that everything's very clean. Like everything's fully covered, locked down. I already spray painted on this, so like I might as well go full, full tinker with it. Yeah, definitely. So like, and the cool thing about it too is I love looking at the file when it's like somewhat fully put together. Like the antenna aren't really attached. I was gonna have the antenna do more this time, but I was just too lazy. But it looks extremely good, which is very important. I just have to figure out the tail part here, or how I'm going to design to cover that. I could just put 2 little rods down here and have it just do that. I'm not sure how well that's going to hold, though. There's always something, everybody. It's always something at the end. Always something. Let's see. Oh, I also recommend art books. Like I know it's like a weird thing for most engineers to think about, but definitely look at the art books of some like favorite video games or favorite sci-fi series, because a lot of artists have to think like engineers when it comes to their design. So a lot of the like nuts and bolts, a lot of times you see it and you're kind of like, at least my brain, it works like, oh, I wonder if this could work or not. I'm not sure if I have one down here under me currently. I don't think I have an art book, but that's a perfect example of coming up with ideas and seeing how things can kind of work and how to make them look good for the camera. Yeah, I think this should work. In theory, this should work. I hope that this works. I mean, we really don't know as of yet. Make it fast, durable, and self-charging. I've thought about that. Okay, so here's the problem. I can make it faster, but I'm going to need more power to make it faster, which will increase the weight. And then these servos are just 5 volts to 3 volt servos, just micro metal gear servos. They're good, but any huge voltage, of course, will fry one. And like I was saying earlier, if you fry one of these servos, that's the entire robot is going to brown out. It just won't work. Making something faster, there's a guy, I forget his name, I saw him a while on the internet. He made a hexapod that was super fast, but he designed his own motor system to make the motors move, and it works kind of like, what do you call those things? Helicopter motors, not helicopter, drone motors. He used like drone motor designs, and his servos That way it can do the crawling motion a lot faster, which looks amazing, but like you had to go fully custom to do that. And I know that took a lot of time. Self-charging probably could work. Like if I had the stuff for it, I would love to make a shell, like this entire red part of a shell. I would love for this to be all fully like a solar panel. So when I'm outside, it'll just be charging a battery. That would be kind of cool. Um, I haven't decided what type of sensor I want to give it yet for it to like see the world as of yet. Because right now it just crawls forward. So I'm like, I'll show you guys again in a second. But a lot of it is just move that out of the way. They can pretty much just crawl forward, but it does that very well, which makes me happy. Ooh, you froze there for a second, buddy. Oh, there we go. So, like, it'll crawl forward without a problem. And that's horrible. That's all I pretty much can do. It's pretty fast, but it's not like crazy fast. Let's see. How do you make the six-legged robot move forward? How do you achieve synchronized leg movement? Do you use a library or do you use code manually? A bit of both. I didn't have a library for this. The only library I learned that I needed was oscillation, which is just like the speed of the servos, which a lot of servos have that. So like a lot of ways robots move smoothly, especially animatronics, they have this like motion where they speed up and then slow down. James Britton made an entire video about it. It's amazing on YouTube. I definitely recommend it. I started off first figuring out where each servo needed to be. So like if you notice when I turn them on, when I press this button, first thing it does is it moves all servos to 90 degrees before it starts crawling. So how I did is I broke it down step by step. I was like, I wanted it first to figure out where 90 degrees is. So I had all the servos set to 90 degrees as I attached the feet. Then I went forward from there, figuring out which leg needs to move where to move what. Since Digit is such a unique design, since it's super flexible, it wasn't like other hexapods. Because other hexapods, which I'll use a quadrupod design for an example. It's already here. It's like the crawler design here. Most hexapods and quadrupods have like a strong flat base, which keeps the body like upright forward without a problem. Since Digit is wearable, Digit's flexible. So like this entire thing here is flexible for it can bend. So I had to come up with a new system for it to crawl forward. And that took me like 3 days of figuring out motion, changing stuff. There was a time where it literally had the wrong motion for it. It was using a tripod walking system where I used these 3 legs and the other 3 legs to walk forward. And then I found out in the code, because the servos are flipped to the other side, it wasn't working because the servo on the other side was moving in the wrong direction because it thought it was a whole bunch of coding issues pretty much. So I had to sit down and like write a whole bunch of stuff down, took notes, and get it just trial and error until I got it walking, which was great. Like it's one of my favorite things. Like it was literally the hardest programming thing I think I've done thus far in my career. I'm pretty sure I'm going to do a lot more harder things in the future, but it was a lot of sitting down on the sheet of paper, testing the code, seeing if it works, testing the code, seeing if it works, changing the algorithm, testing the code, seeing if it works in the algorithm. It was a whole bunch of back and forth of just me going back and forth. And I had other people look at it too. My friend Travis helped me out on it a bit. And even there were some points where even he would just like, yeah, I don't know what's wrong. So definitely, it's just going to take time. Like this is not something I would tell anyone to just jump into unless you're very good at programming, or you already have a already finished design. Because like if you have this was a full simple hexapod where it's just a stiff body, I think would have been a lot easier. Plus, I'm not sure if a lot of you noticed, my hexapod is only using 2 servos per leg. Most hexapods use 3 servos for you can get more of a lift as it walks. I didn't want that because mine is a bug. So it doesn't have as much lift, and I had to like program that out because most hexapod code has that extra, it's hip, elbow, and foot, and this one technically doesn't have a elbow. Yeah, sure. I want to do a whole video about it like crawling and stuff. It's like one of my favorite things. Yeah. 1 second. I'm going to put the camera down a bit more and give you guys a better view of just the robot really quickly. Boop. So like you can see his like back legs actually kind of fold up a bit. So like when I drop it, it does that. But like they also help push it forward. It's super fun. But it also keeps walking off the table, which is a small problem. But yeah, honestly, I'm super happy about it. I'm happy that my little robot bestie can finally walk around. But I still have to figure out about the directional points because like it can only walk forward now. I don't really know how I'm going to like fix it. Oh, sorry, back to me. I don't know how I'm going to fix it yet to get the turn stuff because right now I only have the movement for forward. I don't have a code in here for turning sideways or left or right because then I'm going to have to add subroutes and things like that, which I haven't gotten a chance to do yet. I plan to do it in the future, but I'm going to have to program like, hey, this new walking motion. So when this happens or when you run into a wall, turn sideways by moving this servo, and this over this way. And hopefully that will teach it to go this way or that way or to walk backwards, just do this entire code thing but backwards. Like it's going to be a lot more programming and work that hopefully I'll do in the future, but I also have a day job, so I can't just focus on just that. That's why my next hexapod crawler will hopefully or quadrupod crawler will hopefully have that, but this one will always be different because it's flexible. It's one of those weird things you have to like constantly think about when you're like working on like different robot designs and stuff. Depending on how your robot design, you're always going to have to like get clever with it. I love a video on how you interact with AI, such as your prompts and coding, especially. Yeah, that one I'll happily do that. But like me and Sean did that before, and I've just been editing the same prompt for a while now. I did learn how to train your own AI voice module. That's why Digit's voice sounds like from Arcane. He sounds like Heimendinger because I took a whole bunch of Heimendinger voice lines and trained a model for it, and then just implemented with Piper TTS because you can train your own Piper TTS model. But for the prompting for it, and this is something I'm still working on, I want to focus on tone because I've noticed, and I read a paper on this, the tone of voice for AI, and this is a problem that some companies have fixed, but for large language models, we haven't yet. You really can't tell the tone of the robot. So a lot of the times they talk very flatly. But as we know, as English speakers and anyone who's ever talked to anyone, that depending on how you say it, the tone of your voice could change how everything is. So when AI is talking most of the time, they just have the same tone of like voice, just at the same level, compared to being like hi, where you say like really happy and it goes really high and then going down, or when you say something sarcastically, when you kind of like oh, the tone of your voice pretty much shifts, and I haven't figured out how to program that into my AI system yet. I'm on Instagram, but to be honest, I don't really share digit files, so you'll have to design your own. That's where most of my videos are anyway, currently. I don't have a YouTube per se. I'm on DigiKey's YouTube and I do stuff here. But that's pretty much it when it comes to those like projects. I need to move this. This is bothering me. Oop. And did I save this already? Wait, where are you? Are you? Oh, you're in the wrong body area. Save this. Yes. Scrolling up to Doom, and things like that. Gotta get rid of that. But yeah. So there's a whole bunch of things when it comes to making this type of robot. My next one that I still want to do is still a drone. Like I've never built a drone before, so I'm like excited to try that out in the future. Where's this sketch at? Ah, it's there. Okay. Also, don't be afraid to clean up your designs in Fusion because sometimes they leave like little sketches and things like that out. And I personally like having my design out clean because then it just looks good. So when I look at it later, I can be like, yeah, that looks good. Very important to have a good looking design together. And it's not including all the other stuff I'm probably gonna have to change. Like I said, I'm not sure if the shell is going to work. I'm testing it out today. It may not work, and then like tomorrow I may have to go with a whole other design, which I have an idea for another design for the future. I'm just not really worried about it yet because like I think I can give them a spine and then use like a spine flex mesh to cover the body like that with the shell. But I want to see if I can get this one working. If not, Friday is a thing, and I can use the shell design for Friday's design, and then we'll just go from there. I think it's like the best thing I can do right now as this continues. Especially because I think I have a flex design for a spine that's in one of my files. But robot spines. Yeah. I usually use the AI system for a digit. It's still the one that I've used for a lot of my stuff. It's hooked up to my laptop because I have the NVIDIA board on there. That's what does a lot of the extra work for me. But I haven't really used it in a while because I've been so focused on the design aspect more than the actual AI part. The AI part's a lot more programming, and like I said, I'm not a fan of programming. I'll do it. It'll just take me a while. Not really sure if I feel like sitting down for that long and just going through programming. So right now I'm going to just do scroll down. Nope. New body. That's kind of long, but we'll see. And then I can easily click this, create. We'll go with the pattern. Should we follow pattern? Geometry pattern. Then I go to path. I'm going to select this. Backing. Oh, can I do two sides? Symmetrical. Probably can't do symmetrical. Okay, that figures. Oh yeah, let's go opposite direction. Oops, ran into an error. Sometimes that happens where it doesn't want you to do stuff. Like I said, I'm still learning about it. Oh yeah, you can totally create your own library afterwards. I have yet to create my own library for it. I probably should sit down and do that. I'm just extremely lazy when it comes to, like I said, programming. But yeah, I can totally turn it into Arduino code and stuff like that. I plan to do it later for the quadrupod, but for Digit, I haven't done it because I've just been focused on the design aspects more than anything. But there's already libraries out there. You just have to like I said, if Digit was a normal Hexapod, I would use one of those other libraries, which I'm pretty sure can do all the stuff that I need to do. But since it's a custom design, it won't work the way that all the other ones will work. That's the main problem, is that I went full custom with Digit instead of just following the basic stuff. In the future, I may make Digit bigger. Like, I do have a goal in the future when I make Digit more flexible and stuff to have Digit wrap around me. Very much like if you're into, which I know some people are, if you're into anime, there's an anime called Jujutsu Kaisen where a character has a giant worm like wrapped around his body. And I would love for Digit to get to that size where it like wraps around me like that. I think that would be super fun and super cool and freak a lot of people out. And who wouldn't like that? It would be fun. Imagine going out and seeing this guy with this giant robot wrapped around his body. Especially if it has little feet and pincers, maybe. Oh, yeah, this is not right. Let's try this one. So I can make a wheel there, but we're going to suppress some of these. I don't think I need this one, this one, this one, this one, this one, this one. I need another one. Oh, don't need this one. What else can I say? Wow, it just won't. Oh wait, I'm not on. That's my fault. I should have. I was on the wrong file. I need to move this. Paste. You know, ironically, I have a massage function idea that I've been kind of working on. I've been playing around with these vibration motors. This is one that I took out of something. I don't remember what I took this out of. But I was thinking about adding vibration motors to them. That way it can do that. That way when I wear them, and just like, you know, do that. I'm using an Arduino Nano and a Adafruit, was it PCA6958 servo controller? Those are the two controllers I'm using. Off the shelf. I think later I could probably use a Raspberry Pi if I wanted to like design some other special designs for it, if I make it a little bit more crazier, but this is perfect for what I'm using. I need to use Python more because I know how to use Python, but like I haven't used it in a while. So like now my brain is stuck on C++. But yeah. Let's try this again. Hopefully this time it actually works. Oops. Wait, did not select my body? Oh. There we go. There we go. So now we have this little hinge here. I'm not really sure if it's going to hold it all in and protect the tail of my robot, but we'll have to see. All right, Becky did do a video on choosing a microcontroller for your project, and choosing the right microcontroller can be the life or death of you. The reason I chose the Arduino Nano is because I need something small, and also I'm very comfortable with the Arduino Nano because that's been like my go-to board for a lot of my smaller projects throughout the years. But a good example is if I want just the eye to work, like the eye could be working just with a QT Py and a touch sensor. That's all that's happening here. And gives them like a little cute thing. Like a QT Py is good for LEDs. My clock arm is being run by the QT Py. I have another one on my desk, which I'm experimenting with. Little digit clock number thing, but that one's being powered also by a QT Py. So for smaller projects, definitely use something like a smaller microcontroller. But it all depends because there's a whole bunch of microcontrollers, and depending on how crazy your project is, depends on how much processing power you might need, and also what else you need to connect it with. Because the Arduino has been great for single stuff like this, which I enjoy. But like if I eventually want to add like the full 16 servos plus some extra stuff, I'll probably bulk up to it like an Arduino, a bigger Arduino board, pretty much. Because the Arduino Nano can do a lot, but it still is an Arduino Nano board. I'm not sure which Arduino board that I really want to use for the future, because there was one me and Sean used. I think it was the Arduino Nano BLE33 V2 that has some basic AI capabilities. You could train a wake word for it, and I want to try using that for future projects, because if I can have a wake word and train Digit to have a wake word, I can make him do fun stuff. Oh, Arduino is perfect. Like if you have, sorry, a Raspberry Pi. Raspberry Pi is definitely perfect. Also, point out tomorrow's Pi Day, so you know. But yeah, no, and Raspberry Pi is perfect. You can definitely use a Raspberry Pi for this. The only reason I didn't was because this has to be worn, and I have a Raspberry Pi Digit that has a camera and stuff installed. So it's in the corner. I'm not gonna go grab it right now. But that one works as well. The only thing about it is that since this is wearable, I have to think about weight and power problems. The Raspberry Pi works, but it's also very much a power guzzler, so you have to have a power source that can feed it when it needs to be operational. So if hypothetically, if I make a bigger hexapod in the future, where it's just like the plain base, not none of this flexible stuff, I probably would use a Raspberry Pi because then I can make it do other stuff. I have thought about it. It probably will be a future project where I make like a giant hexapod using like huge servos and stuff like that. But the base will have to be pretty big because I'm going to have to customize the power because a lot of the bigger servos are like, I think, what, 7 volts of power, 5 to 7 volts of power, plus the current, plus powering the Raspberry Pi. So I would have to definitely customize the power source and have a big platform to make it work. But if you're just going for a simple hexapod or a simple robot Raspberry Pi, 110% go for it. I 110% recommend that. All right, I think we're done for this. So I guess I'll just go to my my top down. People can see this, kind of fun. Yeah, here, let me show you guys the motion of the top down crawling. So you can see another area of it. Dun, 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 moving all this stuff out of the way. I do apologize for my messy desk. If people who follow me know that my desk is always a mess because I'm always working on something. The only time it's really clean is when I have to like record a video, and I try to make it as clean as possible. Keyword as possible. But like, click this button, turn on the power system, and then I click this button to make it crawl. Okay, you can kind of see it as it goes. Oops, move that down some. Go, my digit, crawl. It's pretty fast, honestly. I need to like measure the speed, but perfect for like fun little videos and hopefully to carry stuff. Eventually, I want to design a way for it to move on my arm and crawl it by itself instead of me totally picking it up. But yeah, but I have to cover all of this, so that's the problem. That's the main goal. That was the main goal for today's stream, but wait for prints to print out now. I'm not really doing much more than that. Oops. I guess what I can do is honestly not really sure what I can do right now. If you guys have any questions, I'm open to hearing them. I think I have all the design stuff I could do for right now for that. Let's check my printer. So printer's going pretty good. Pretty good. That should be done pretty soon. That'll be the first real test, especially with the TPU. But it looks like it's coming across pretty great. So yeah, if you guys have any other questions, I'd be happy to answer them while we can. I'm not sure how much more time we have today for my office hours. Oh, I see someone put inverse kinematics. Yeah, definitely have fun time learning reverse kinematics. Fun thing. Geometry is not my favorite subject. I didn't really learn geometry in school, so having to learn reverse kinematics myself was an entire like month of me just making problems and solving them. But you can figure it out. If I can do it, you can do it too. I skipped a lot of the basics of geometry when I was in school. I don't even think I had geometry class in school. Now that I think about it. I had figure drawing, and that's kind of like geometry. You gotta get the measurements correct on a human body. But yeah. Let's see. Do I have anything else to share with you guys? Let's see. Give me a moment. I'm trying to look through my files here. Yeah, my computer is being weird. Yeah, so that's pretty much. I guess I'll do some more CADing. Just gotta work on this design a bit more, which is just fun. I'm went for a basic animatronic eye design, but I want it to be a single eye. So I'm still playing with this, but in theory, this should work. Should move the way I want it to move. Is that body one? Yeah, it is. Also, you guys can see how ADHD I am when it comes to like working on projects. Because while I'm waiting for prints to start or finish, I am working on something else on the side. Ooh, that's going to be a problem. Extrude, give me 2 millimeters on that, please. Thank you. That shouldn't be there. Delete. Okay, fine. I want to delete now. Just extrude you too. Extrude, extrude, extrude. Join that there. Then I'm just going to go here. Delete. Ta-da! Smooth. So in theory, to get this part to move this part, which is what I wanted to do, I'm going to have to design a way for it to be on the same movement area. So I have to add some type of holes there. So I'm going to click this here, this. Honestly, it's kind of like working with clay a lot of times. If you ever played with Play-Doh or had to sculpt anything, that's pretty much how Fusion works in my brain. I'm just like sculpting with just basic shapes until something looks cool. So, doing this. Add that there. I think that should be pretty good for that. So if I have something like a, let's say hex screw here, screw that in. Actually, no, hex screw wouldn't move that. I need something that'll be fully open with this. So this needs to be bigger. I'm sorry if I'm just like rambling about. I'm literally, this is literally how my brain works while I'm working. I just start talking to myself. And make that bigger because it's just going to hold the pieces together. Yeah, so I just have to find something that will. If I use a rod wouldn't work. A rod wouldn't work. It would have to be something like a heated insert. Which, if it's going to be a heated insert, what's the measurements of this? Oh, it's 4. Okay, it's a 4 diameter hole. That's good. So that should work. What about turning? Turning could work a bit. I may have to fix some stuff, but in theory that should work. So this servo should pull on this and give me that up and down motion I want for the eye. Honestly, I think the eye is too big for the faces of the hole. Maybe I should make the eye smaller. This is an LED dot matrix, just in case people are wondering. This is just a file I have for it to remind myself that's where I want to put it. But I may not go with the dot matrix. I may go with like a basic robot eye, like a single LED, you know? That may work a bit better. Yeah, we'll go with a single LED. Which means we're going to have to curve some stuff in. Let's see how far we get before. Well, no. No. We're getting too ahead of ourselves. It's fine. I'm only human after all. I'm only human. I made a flaw, so put the blame on me. Don't put the blame on me. Okay, move that there. That way a small LED can be used, and then we'll cover something up with that. That's fine, that's fine. I'm slightly worried about the eye being so forward, though. Also, this looks ugly. So let me go here, cut this out. Oops. Good. Yeah, it's much better. Don't really like how that's folding up. Stop it. Yeah, that'll make inserting the eye a lot easier. Now the question is, how am I going to design the rest of it? So if I move that down, side more, then we have a decent looking hexapod head, which I may have to move it up a bit because of the fact that we cannot have that servo touch there. See, this looks good when the gravity gets involved, and then I have to worry about that because this is too close to this, and then it being so forward, only having 4 legs, that may actually make it lean forward too much and not walk. So we may have to come up with a different design and put this in the back. So let's put this in the back. I'm going to raise it up a bit. Dun, 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 dun. Yeah, basic design, nothing too crazy, but still looks good. And then that way I can put the power system and other boards on this, and that will save me some time in the future, because that's how that's supposed to work. I think I may make this a decimal bot. Yeah. Or in theory, if I can get the weights of it distributed correctly, I could do something different. I could. I'm just gonna type this as I could, in theory, component. Capture position. Make it super, super basic. I'm always a big fan of the single eye. I feel like 2 eyes are too human. I designed it to go this way a bit. Then I can put this, move this. This. Simple shapes, simple shapes, simple shapes. Grab this, move this upwards. Well, yeah, one side should be fine. New body. Boop. Boop. Press pull. Into a round shape. Boop. Turn off the legs really quickly. Come down here. Shell it to 2 millimeters. That way it's more of a cup in there. Boop. Yes. Okay. Now we need a way to attach stuff to it. So we're going to take off the leg quickly. Put your mind at ease. If you relax, I will make I will read your future like a single mouse on a tune. I look deep into your heart and soul. Make your wildest dreams come true. Let's see if we like that one. Access. Extent. Let's see. I designed it like that, and then that goes on top. Yeah, I can see that working, but we're still gonna have to get in there. Maybe a better design. It's more simple. The servos don't get in the way. And keep the weights off of it too, as long as the battery power isn't too wide. Yeah, I can see this working. What I'm going to do is click this pattern. I mirror this. Yeah, no, I'll mirror that. Okay, fine. Mirror. Absolutely not. Not what I wanted, but I can definitely work around this. That'll work. Okay, that's done. Legs. Appearance. Show. Plus red. Is that purple? Yeah, it's purple. Can use purple. Yellow, purple, white. Another color. All the power of the rainbow. All basic colors. Yeah, that'll work. Very important to have the appearance center. Yeah, that's gonna bother me. Oop. That's like basic though. I gotta have a better one. Ugh. Bones popping, getting old. Move it on, move it on, move it on. Back and forth, back and forth, back and forth. See, if you're a professional catter, I always give you props because I had a colleague who was a professional catter, and it looks like fun, but it feels weird still. It's not right digit. Yeah. Don't worry, buddy. Don't worry. Your parts are coming. They're both printing out. If you're wondering what I'm currently doing, I'm just making a second option for this quadrupod that I'm going to build in the future for work stuff and for open source projects. I like the first design, but it may have a weight problem because that's something you have to think about when you're making a quadrupod. Or a hexapod. You have to think about weight and how it folds and stuff. And the first one had the eye way too up front. Like it looks good, but like I wanted this eye to be way up front, but noticing with the servos and stuff, that would have been a lot of weight. Yeah, having the eye up there would have had a lot of weight, and I'm not sure with the current servos I have that it would have had the ability to walk correctly because its head would have made it front heavy. And then as soon as something moves, there's a good chance that it'll just top over too much. So just in case that is the case, because I still would have built this eye, I think it's super cool. But just in case that's the case, I'm working on a second version, something that can just easily attach to the base and don't have to worry about it. It looks basic, and I agree with that, but sometimes you gotta go with a basic design to get good results. Not everything has to be super flashy. I know there's probably a person somewhere who's saying blasphemy, but you know, not everything has to be flashy. Oops. Actually, just to make sure that's correct, because that's going to become a problem in the future, I can tell. Align bodies. This. Perfect. Now I know exactly where it's supposed to be. Honestly, I think this little dome thing I made here could be used as an acrylic dome. That way we can tint it and then give it like a little LED in the middle to make it look like a more of a thing. I think that could work. Also, the reason why I was working on this and putting like holes up top is because we're gonna have to screw this body in. Actually, I should probably do that now. Always think about assembly when you're working on stuff like this, because you don't want to be in a position where you're printing out parts and then realize that the screw can't fit in the hole or you can't reach a certain area of your design because you didn't think about the complications that will come from adding and attaching stuff. And definitely, when you design stuff, you should always expect that you're going to have to take it apart because that's always going to happen. Something always is going to go wrong. A battery may fail, a servo might burn out, and you might get a brownout. Um, and that's going to be a big problem. So let's I have about like more 15 more minutes. So if anyone has any questions or things they would like to say, please say them now. Mainly because I'm really bad checking my messages on my other social media platforms. I'm not gonna lie, I kind of ignore them. So this is a perfect time for me to like talk to people without having to like look through my 99 plus messages. So if you have any comments, concerns, or ideas, please let me know now. Yeah, that should be fine. If not, I will not be able to answer them until the next live showing. Boom. See, I intentionally made the hole on top bigger because I already know I'm gonna have to fix a screwdriver because I'm hoping. Ooh, these on the bottom though, I didn't want these to be this big. All right, I'm gonna have to fix that. Uh, oh, actually, I have an idea to fix it. First, what we're gonna do is get the rest of them like that, and then what's the diameter of this? 28. Okay, that's fine. Oh, no, it's not 28. That was a lie. I must have read that wrong. 2.8. No, that wasn't it either. About 5 or 6 should do. What's 6? Yeah. Okay. Yeah, that works. I'm gonna have to fix these though. I wonder if I can just delete this part and fix it. Nope, it closed the hole completely, didn't it? Yep. All right. Take a step back, step back, step back, step back, step back. Okay. First, inspect. This is actually a 7 millimeter hole. Write that down. Thanks for hanging out with me. I definitely appreciate it. Like I said, I want to do more of these and make more videos and more content and stuff. The main problem with making like new stuff like this, it takes like weeks for me to hyper fixate on, and I never have enough time to like sit down and just make idle videos. So how I'm trying to do things now is I give myself a little free time after each project, and then I just make a whole bunch of videos. So like my plan is to finish Digit. With Digit is done, I plan to make the Orbit video. I'm gonna do at least 3 how they're made videos, and then do some fun Digit story time like videos, and then that's what that'll hold me over for a minute while I start working on the next project, which is probably gonna be this quadrupod, if not the drone. At least that's my plan. Yeah, measurements were way off for this one. What we can do is we can cheat our way through this. 53. That's pretty close. We don't need to be perfect. We need to be somewhat in there. 53. Let's see. 52. Let's see that. Ooh. Well, some of it worked. The parts that I wanted to work, but some of it worked. Okay, so now I know that won't work because the computer gets confused. What we're going to do here is just get right in the middle where we can. And now that we know it's 7 millimeters, I'm just typing 7. I'm just going to do this for all of them with that. So, so that'll work. See, this is just where I can stick a screwdriver in there and screw in these screws to attach to the body, which should work in theory. Let's see if I can fix this real quick. Ooh, did not mean to do that. Search. Okay, that works. Yeah, I think I'm gonna use a little dome for that. A little clear dome. This join cut. Now we have a little straight directly into the head, and we can attach an LED to it. But like the rest of this, I'm hoping it has enough room for small, I want to say flat batteries, and then the circuit board in there, and it can work. The reason Digit here needed more power was because it's bigger, but when I was using the quadrupod design, I didn't need that much power. I think I used a single power booster and a 3.7 volt servo, 2,200 milliamps. But if I can make it work on a very small power source, even for a little while, then we can make that a cool thing. So the back looks kind of basic. I'm gonna have to go back here and make some cool stuff really quickly. That's a bad line. Oop. Cut that off. Perfect. Screw, say 4. Join. This. 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 Axis. I think 4 would do. At this point, I'm just decorating. Sometimes it's nice to add a little flair by just carrying out basic shapes into certain things. And you can make them look more sci-fi that way. Like, it brings it out a bit more. And then to give it a little bit more, yeah, oh, that's too much. Back here, I want to do some more stuff. Got about 4 more minutes. Oof, oof. Don't know that second thing I clicked, but it did almost mess me up there. See, and just like that, a little small, little detail, and we have a cool backside. That's a weird sentence. Then we can add an antenna back here, make it look more sci-fi. Let's see if I can do that in 3 minutes. A race of the clock. Can he do it, ladies and gentlemen? And others, because let's be real, not just ladies and gentlemen, there's non-binary people as well. Can he pull it off? Maybe. We'll see. Figuring it out now as we go. Don't know how that's going inside, but we will. All right, go down. Nope. Join that. 2 side. Going up 1. That's here. Get rid of the legs. Let's do that. Go inside here. Delete that. A small hole here. 4 millimeters in the middle. Oh, we can have a screw type of antennae, but like, so now we can put an antenna there without a problem. And that's kind of cool. I like that type of stuff. All right, got 1 more minute. Starting to placement holder. Close. Legs. Design. Boom. So yeah, when I design the crawler, it'd be something like this. Something small, simple, sci-fi-y. Like you look at it and definitely scream sci-fi-y. And yeah. I'm pretty much out of time here. I have literally like 30 seconds, and I don't want to keep my crew after they have to. Last thing I want to do, ironically, I think my printer just stopped. Yep, it just stopped too, so it's perfect. All right, everyone. Thank you for joining me for this live. I'm going to definitely have office hours in the future with more of my projects that I'm currently working on and will be working on. If you have any other questions and things along that side, please let me know. Bring your questions to the live. I'll happily answer them here. And for the rest of you guys, have a great rest of your day.